Hey folks, how's it going? Mr. Murray coming to you with a quick little tutorial on synthetic division, also known by my buddy Mr. McCready as the bus. Alright, so in this video I'm going to be breaking down real quick some examples of how to do synthetic division. This is an alternative to the box method that we learned through the Polydoku activity. You're of course welcome to use the box if you'd like, or you can learn synthetic division. You got to know how to execute one or the other. So what we learned through the box is that it was a really nice way of using a puzzle-based format to figure out how to do polynomial division. But what we also saw is that what it came down to was we didn't really care as much about the powers of the variable, in this case r, as we did about the coefficients, the numbers in front of the letters. And so what we're going to be doing in this video is seeing a really nice and elegant way where we just use the coefficients 1, 2, -7, and -12 to set up a method that's actually really quick, okay? And it's called the bus, okay? So this is a bus that I happen to be driving, and basically we got our buddies in here, 1, 2, -7, and -12, and they're riding the bus, okay? And then kind of outside, and maybe even you can consider the driver, is -3. And I'm going to show you real quick how this bus works. So our buddy 1 here, it's going to come down as 1. All right, and we take the number 1, and we're going to multiply it by -3. Okay, we multiply it by the number on the outside. And by the way, -3 is chosen because it's the opposite of this +3. It's going to sit with 2, okay? It's hard to see, but it's sitting there, and so I put it underneath because it's sitting there. Then what I'm going to do is I'm going to add, and what I like about this method is that it involves multiplication and addition, which is often easier for us than subtraction, though it depends who you are, and I respect that either way. So 2 minus 3, that's going to be -1. Then we're going to repeat it. We're going to take the number here and multiply it by the number on the outside. That's going to give us, in this case, 3. I'm going to do that in red so it stands out a little bit more. Then we'll come down again. -7 plus 3 is -4. I take -4 times -3. I get +12. And I add through, and I'm left with 0. And so what this tells me is the answer to my problem. I go right to left and fill in the powers of x. What that tells me is the answer to this division problem is, now because they're 1, I'm just going to write x squared minus x minus 4, and this tells me that there is no remainder. This is always the remainder. Okay, so a couple of things that's nice about it. We only rely on the coefficients, and the remainder stands out to us, that is, right away. And so remember, one of the challenges with the box method is that you had to really think through and, be using some logic to figure out the remainder. Whereas here, the remainder jumps out right at us. And actually, here's another cool thing. What if I plug -3 into this equation? Ready for this? This -3. So I get -3 cubed plus 2 times -3 squared minus 7 times -3 minus 12. Let's take a look. I get -27, okay, plus 3, 9, 18. Plus 21 minus 12. -27 plus 18 is -9. -9 plus 21 is 12. And notice how 12 minus 12 is 0. So this method is actually also called synthetic substitution, because whatever you get for the remainder is a number such that it's what you essentially get when you take the opposite and you plug it in. So, and that means that the remainder being 0 means when I plug in -3, what comes out is 0. And this is actually very important for factoring polynomials, and that's something that we might see if we investigate some more advanced factor theory. Okay. All right, so let's go into some examples of the bus, and again, I'm going to show you the setup. So we don't have the bus as a visual aid, so I'm going to set up my makeshift bus here. Okay, outside, I'm going to target this. This is a +2. I'm going to write a -2, and then I'm going to write 1, 9, 8, -17, and -10. Note that we're generally going to use this strategy when the number in front of the variable here is 1, and notice how it's just v. There's no v squared or anything like that. So there are some restrictions as to when it's going to be practical to use this. Okay, so we need to make sure the number in front of v is 1, and it's just a v. No v squared, no bigger power of v than v to the 1. All right, so we bring the first number down, write it as is, multiply by the number on the outside, giving us -2. Add down, we get 7. Multiply by -2, we get 14, -14. Add down, we get -6. 8 minus 14. Multiply, we get +12. Add down, we get -5. -5 times 2 is 10. Add down, we get 0. Okay? So what's my answer? So again, you go right to left. No x's, 1x, x squared, x cubed. So our final answer is x cubed plus 7x squared minus 6x minus 5. And so you can see that we tackled that problem a lot quicker than with the box. But let's take a look. I'll do one with the box. So remember, we set up x, and this is going to be x plus 2. Well, in this case, I guess we're going to do v plus 2. So in theory, I guess I should be technical, and I should, if I started with v's, I need to end with v's. So v cubed, v, and I suppose we should do the same thing here. It doesn't super duper matter. I mean, changing the letter alone doesn't really make a big deal, but it is important to stay consistent. Okay, so here we're going to do v plus 2. Okay, and what we need to do is, and I'm going to copy this down so we can see. Okay, we're going to do the same problem and show that we get the same answer. Okay, so you can see the box really is working. Okay. Okay, so to start off, remember we put our v to the 4th in the upper left. So this has to be v cubed, so this becomes v to the 4th. So this is 2v cubed. We need 9 total v cubes, so 2 plus 7 equals 9. And again, I didn't care about the v cubes, right? My big focus was on the powers. So then this has to be 7v squared. So 7v squared times v gives me 7v cubed. This becomes 14v squared. Here I get -6v squared because these need to add. And so again, the difficulty is how to think about the adding. You really eliminate that a lot with this synthetic division method. This has to be -6v. So -6v times v is -6v squared. -12v. So this has to be -5. So they add to -17. This is 5. And this times 2 is -10. And since the -10 and the -10 match, there's no remainder. And our solution is v cubed plus 7v squared minus 6v minus 5. Okay? And so we again see we get the same exact answer either way. I leave it to you, though, to consider which one is quote-unquote easier for you. Again, the advantage of the box, no matter what you're dividing by, the box will always work. If you're not dividing, if you have a number in front of the v, the synthetic is going to involve more thought. If it's v squared you're dividing by, the synthetic is going to really not be an option, so there's a lot of things that are cut off. Here, every single thing works, but there's a lot more thought that goes into it. So you got to think about under what scenarios you're going to want to execute each one. Okay? All right, back to synthetic. Let's take a look. So again, I'm going to draw my box. Okay, 1k to the 4th minus 9k cubed, 27k squared minus 20k, and 11. This is a negative 4, so I'm going to write what outside? Positive 4. So I bring the 1 down as 1. You leave it alone. Multiply by 4. I get 4. Add down the column. Negative 9 plus 4 is negative 5. Multiply by negative 4. I get negative 20. Add down the column. I get 4. Multiply by 4. I get 16. Negative 20 plus 16 is negative 4. 4 times negative 4 is 16. Add down the column, and I get negative 5. So let's just check this. Again, you bring it down, multiply, add, multiply, add, multiply, and so on and so on. Now, if you do make a mistake, it is going to throw off the rest of the answers, so that's why you want to be super duper cautious there. So again, these are k's, so I'm going to backfill it. So this is, remember, the last number is always the remainder. Okay, so I'm going to go no k's, 1k, 2k's, 3k's. Okay, so I get k cubed minus 5k squared plus 4k minus 4, and here's my remainder, plus negative 5 over the thing you're dividing by. In this case, I'm dividing by k minus 4. So that's how I write that. Be super duper careful with how you write your remainder. Okay. If you need to go back and review anything that I did, I encourage you to do that. And in a couple seconds, I am going to move on to another example. Okay. All right, folks, help me out. So first thing I do is I set up my bus. What is going to go on the inside? I'm going to write 1, 2. Now look at this. There's no, this is the very, very, very big downside. Notice how there are no x squareds. You have to write 0. You have to. If you do not put the 0, you are straight out of luck with synthetic. You're going to get the wrong answer every single time if you do not fill in the 0 coefficients, okay? And that is the biggest thing that people make a mistake with synthetic, and that as a teacher is the biggest thing I fear about synthetic, is people forget to do that, and it makes a huge difference. So you need to put those 0 coefficients, and it's so easy because you don't see an x squared. You think to move on, but you have to remember that, okay? So tragic when people forget that. All right, and then outside I'm going to put a negative 2. Now, again, with the box, you wouldn't worry about the 0 coefficients. You would just try to get them, remember we said, oh, get them to cancel out. Okay? All right. So, again, we do what with the 1? We bring it down. Now, the number in front of this can be like this. This is a 1. It could be a 2. It could be a 5. The number in front of here is whatever. But remember, the number in front of the right, the thing you're dividing by, the leading coefficient needs to be 1, and the biggest power of x needs to be 1. Otherwise, we get into a whole bunch of doo-doo. Okay? So this becomes 1. We multiply by negative 2. We get negative 2. We add down. We get 0. We multiply by negative 2. We get 0. We add down. We get 0. We multiply by negative 2. We get 0. We add through. Now we're going to get something a little bit more meaningful. We get negative 4. Multiply by negative 2. And we get, I believe, 8. And now we're going to add through, and we get 3. Okay? So what that ends up with is, this is nothing. This is x squared, and x cubed. So we end up with x cubed minus 4 plus 3 over x plus 2. And so let's see if we try to test our answer by doing multiplication. So I've got x plus 2, okay? and I've got x cubed minus 4. So let's test this out. X to the fourth minus 4x plus 2x cubed minus 8. And if I combine like terms, x to the fourth plus, remember it's standard form, 2x cubed minus 4x minus 8. And you might think, wait a minute, that's minus 5. But when you add in that remainder of 3, you get x to the fourth plus 2x cubed minus 4x minus 5. And that takes you right back where you started, proving that though it looks strange, this is in fact the solution. So again, if that was confusing, very much encourage you to go back and rewind and take a look at anything I did. But then when you're ready, go ahead and we'll move on and take a look at another example. All right, so let's set this one up as we've done before, just showing you a more complicated example. Let's do what first? We set up the bus. Outside we put a 8, and the numbers inside are -6, 53, okay, 4, 3, 2, -41, 6, and 16. So you can think about boxing this, how tough it would be to add up to all those big numbers. Now we're not going to focus on that. We're not going to try to get to adding up to -53, right? First, we're going to do what? Bring down the -6. Then we're going to take the 6 and -6, that is, multiply by 8. That gives me -48. You can use a calculator for this. That gives me 5 when I add. 5 times 8 is 40. So it's a lot less intimidating, right? I add that, I get -1. This becomes -8. This becomes -2. This becomes +16. And these cancel to 0. Now I backfill, no x, x to the 1, x to the 2, x to the 3. So that gives me -6x cubed plus 5x squared minus x minus 2, and no remainder, so I leave it at that. Okay? So again, rewind if you need to, but I am moving on to the next example. This one not so bad. So here's what I want you to do, folks. I want you to take a moment and I want you to please pause the video. I want you to try to do the best you can to divide this. Think about there's a little trick here. And then when you're ready, unpause and you can see what I got. All right. So what we're going to do, set up the box, and we have 1a squared, no a's, -28. And what's going to go out here? We're going to put a 5. Beautiful. Okay, so given that, we're going to go ahead and get started. So we bring down the 1, gives me 1. 1 times 5 is 5. 0 plus 5 is 5. 5 times 5 is 25. -28 plus 25 is -3. So we're going to write, again, work our way back. Okay, no a's, 1a. So we have a plus 5 minus 3 over a minus 5. Or you could write a plus 5 and then add -3 over a minus 5. Okay? So please make sure you understand how I did that with the synthetic division. And then in a moment, we'll move on to one last one for you to try. All right, that was super tricky because of that zero coefficient. One last one, no zero coefficient tricks here. Please take a moment, pause the video, attempt this one on your own. Then when you're ready, unpause, and we can see if you and I got the same thing. All right, let's get it. So here we go. Set the box. The bus, that is. 1n cubed, 13n squared, 40n, 26. This is a plus 9 here, so we'll set our negative 9 on the outside. All right, we'll bring down the 1 as 1. Multiply by negative 9, that gives negative 9. Add on down, that gives 4. Multiply, that gives negative 36. Add on down, that gives 4. Right, and then we get another negative 36. Add on down, that gives negative 10. So that is, let's work our way back. We get n squared plus 4n plus 4. So you can either write it like this, minus 10 over n plus 9, or you can write it as n squared plus 4n plus 4 plus negative 10 over n plus 9. Either way is correct because they are mathematically the same thing. All right, so I hope you found this video to be helpful, folks. This was all about synthetic division, or the bus method. So hopefully you guys have found that the setup for the bus method is pretty consistent. We take our coefficients, we write them in that little bus, remembering any zero coefficients if necessary, right? We saw a couple of examples. One example was here where we had no x squareds. Another example was here where we had no a's. So we got to be super diligent about that. And all we're doing is we're bringing down, we're multiplying and adding, multiplying and adding. So we take what usually would be something like division and subtraction, and we're turning it into something where it is multiplication and addition. So folks, keep at it. Again, you have a couple ways you could do it. We have the box method, we have the division synthetic method, whatever works best for you. I just want you to have a method that will work and will lead you to the right answer. And I know this is tough, folks, so we'll keep it up, stay positive, and remember, you can do it. All right, thanks for watching, folks. Feel free to subscribe if you want to check out future videos. Don't forget to love math, and you have yourself a wonderful day.